So we're looking at the surface area of a cone today. And the surface area of a cone is given by this specific formula. Okay. I want to draw some references in this specific formula. First of all, this is a cone. This is what we're talking about. And the measurements we need in order to calculate the surface area are the height of the cone, the radius, that's the circle at the bottom of the cone, and the side length of the cone. Looks like makes a triangle. We're going to talk about how to create that shape. And usually they set them up with nets. First of all, I think we all know how to create the shape on the bottom. It is simply just a circle. And if we have to find surface area is the area of the face at the bottom, and then the... Oh, I was supposed to make it big. There we go. Then all of the face around the top of it. So, how do I find the area of a circle? What is our formula here? That's right. So, if this is our r, the area of it, of a circle, is equal to pi r squared, which is this part of the surface area formula. We have that covered. Now, the upper part of the cone is actually made by cutting a circle into a certain section. Okay, so I've highlighted, we'll say that this is the section, and you stand it up and connect these two ends, and it would create this type of shape here. If you guys have paper, you can maybe try it after, cutting out a circle and then cutting out a specific section of it. Okay, depending on how large of a section, you could make it a very small section or a very large section all the way around. Will really differ in the height of our cone. Okay, and this is how we calculate that area. The area of the upper part of the cone is calculated by pi r times the side length. Okay, so in this question here, they've given us a cone with two measurements. What are the measurements they've given us?
8 centimeters for the height and 3 centimeters for the length.
That's right. So our height is 8, and our radius is 3. What are we missing? That's right. We need the side length in order to figure this out. Okay? So, how can I calculate the side length of this cone? That's right. That's right. This creates Pythagoras Theorem, right? This is our right angle here. So we're making a right angle triangle. So we're going to use our Pythagoras Theorem to solve it. Remember the formula says c squared is equal to a squared plus b squared. And we're going to replace each of these letters with values or variables. So what would our c be in this case? S. So we'll replace it with s squared is equal to, what would a be?
3.
Yeah, 3 or 8, it doesn't really matter. We'll say it's 3 in this case. 3 squared plus 8 squared. So we'll work through this. S squared is equal to 9 plus 64. What does that equal? Great. And then from here, how do we isolate for s? In order to move over this power, it becomes a square root. S becomes what? What is the square root of 73?
10.
8.5.
Wait, so it's going to be the same on the other side too?
Yeah. So our S in this case is 8.5 centimeters. Now for our formula, do I need that height?
Yeah.
Is the height included in the formula? No, the height's not included in the formula. It's not important for what we're doing here, but it is important if we didn't have the side. Okay? So if we're just given a radius and a side, I can find surface area. I don't actually need the height. But if I'm not given the side, or maybe I'm not given the radius, but I'm given the height and one of these two, I can use that information to solve for the other one. So now that we know that, let's get into our surface area formula. Our surface area of a cone is equal to, what was it? Pi times r times, yeah. And then what?
Plus pi r squared.
Pi r Squared, good. So even by our colors, you can tell we used blue to represent height. Blue's not involved in this formula, right? We just need the red, which was the radius, and the green, which was the side length. So let's plug those values in. What is R? Okay. So pi times 3. What is S? 8.5 plus pi times 3 squared. Good. Okay, so let's work this out. We're going to work out pi last. First, we're going to work out what 3 times 8.5 is. And even though that's the last part of the formula, there's a rule with multiplication. It doesn't matter what order we multiply things by. So 25.3, sorry, 5, times pi. So I'm going to call it 25.5 pi, plus, what is 3 squared? 9 pi. Now, I'm going to show you a trick here. Instead of doing this twice, I can calculate this part, 25.5 times pi, plus 9 times pi. I want you guys to think of pi, though it's a constant, remember it stands for a variable. I can put these together. What if this was x? Can I combine these like terms? Yeah, so these are technically like terms. And if I was to combine them, what would I do? What would I do with the values? If these were both x's, what would I do with these coefficients? I would add them. I would just add them together. So let's just call these pi in this case. Okay? So I'm going to add the coefficients together. If you would prefer to multiply them and get the large decimals, that's fine. But I'm going to add these two together. 25.5 plus 9, anyone know? And I just keep the pi at the end. This way, I only have to do one step of multiplication in my calculator. Okay? So this was plus 9, 34.5, and I'm going to multiply it times pi, 108.38. 108.38, and this is centimeters what? Squared, because it's surface area. So we're finding the area of this